What does it say? Allow Google Chrome to find devices on local network. Don't allow. Hi guys, can you guys hear me well? Hello, hello, hello. Am I audible? Am I audible? I just took a head bath. That's what I have done. I just took a head bath right now. That's what. Okay, I need at least. Okay, as the clickbaity title suggests, what does the title say? Title says that I need at least 10 viewers to start. Okay, we have 13 viewers already. Let's go. So, as the clickbaity title suggests, what does that say? Like the video, too, guys. I don't have much energy, but maybe I'll solve some problems. Maybe I'll try to. Who is Naman? Hi. Is it Naman Gupta? No, someone else. Hi. So, like the video, too, guys. As the clickbaity titles. Okay, I'll share my screen now. Oops, I have to quit and reopen, it seems. 1 minute, guys. To share my screen, it's a new laptop. I have to quit and reopen. So just wait here. I'll just come right back. I think now I can share my screen. Okay, we have 10 likes, not just viewers. Now I think now I can share my screen. I need viewers at least to continue. It shows 7 somehow. I think now it should show at least 20 or 10 or so suddenly. Uh I don't know why it shows 10. 7. Are there more people then? Are there more than 7 people? Okay, as the clickbaity title suggests, like what you do wrong in competitive programming. Why I'm going to tell you this is this fine now? Is my internet fine now? Yeah, I think it should be fine. Fast.com. I'll try to show you guys that. I have good internet. See? 460 MB per second. If lighting goes down, maybe I'll turn on the light. Now it is sunlight, I think. So, guys, as you guys don't know what you do wrong, I thought I will try to tell that to you so you guys can realize, like, because you don't try to notice what you do wrong, or because you don't try to notice what to do. I'll try to tell that to you. That's why I just did this stream. Maybe I'll solve some problems too. Okay. Today I'm not giving coder. Okay, sorry, we don't have time. Is there coder contest? I think I should be giving, but I'm not giving somehow. I should be giving this. Sorry for the clash. Should I end it within 30 minutes and then do this and then start? No, I have some other work too. I have some work. So I cannot be doing this. I think I should give that. My rating is low. Maybe I have to improve my rating, right? I should give this, but it's fine. I have some other work. I have to pack. I finally left Apple, I guess. Like I gave my resignation. It's done. I'm joining a startup company now. Uh, it's not even wrong thinking. Like I will tell you people what you do wrong. Okay, we have 36 viewers somehow. All of you people like the video. Okay, so yeah, let me open VS Code and maybe. Okay, this was last contest, right? Maybe I'll make a new folder. Streams. No, so sorry for taking away at coder beginner, but I bet you guys won't be giving contests, right? You won't be giving contests, but you want to buy courses somehow. If light goes down, I'll try to on the switch. So what should I name this? Last time I made something like what you do. Maybe that's fine. Maybe. So if you try to see, take any problem, I will just maybe say what you do and what to do. Okay. I don't know if these are good titles or not, but let me try. I think given a problem, what you guys will do in general for any problem. I think whatever I'm telling is for any problem, not just for ad hoc or something like that. Okay. Yeah, I am hard stuck on master or international master, but I know what to do. I will slowly improve maybe, because I have solved much more difficult problems. It's not visible here. Maybe I'll add that. Code forces practice analytics. It's a new laptop. I don't even know if VS Code works, but I think I have solved more difficult problems here. See, I solved 97 2400s, 17 3000s, all on my own. So maybe I can achieve GM at least slowly, or maybe I'll come down again. I don't know. But yeah, have patience, guys. We'll learn something here, okay? Even if you're hot stuck on expert, newbie, or pupil, or even master, I think it's the same rules because I'm not trying to give you some tips that along the light. I'm not giving tips that will help you. I'm giving general tips. Like, okay, I'm trying to give you general, very general tips. So, what you do is you will try to find some procedure. You will only try to find some procedure. Find or guess some procedure that works when you submit. You don't even prove it. So if this is what you're doing is you're throwing the problem away. You're throwing the fact that what are facts, like we know golden rules are true, but what we know is you're throwing these things. If it was a heuristic problem, then you don't know if the problem is perfectly solvable. Okay, see the difference, but it is not. It is a CP problem with test cases, checkers, and right solution exists because someone wrote the problem. Correct solution already exists. Like a simple solution already exists. You're throwing all these facts away. You're not using these facts. Okay, I mean, golden rules, my golden rules implies these things, but if you believe in them, then you can imply all these things. Okay, if you believe in them, but then I think believing in something is not easy. Maybe it takes intelligence to believe in things strongly. I don't know. But because believing in things is difficult, I'm just trying to more break it down and show you people that you should not just try to get this thing. You should realize that there is a proof. There is a simple proof. You have to believe in them. Like, because it's a CP problem. It's not like a heuristic problem. Okay. So what you do is mainly this, I guess. Like, you don't even look at the problem. So yeah, we have asphalt 8. But should continue with CP or not, or do dev skills or other things, as CP requires a lot of commitment and internship or play. I don't think CP requires a lot of commitment. Am I committed to CP? Huh? I mean, I'm doing sometimes, but if you see last year, it is even less. Here I was, maybe. Like, see, I'm telling you, CP is not about practice. You have to be smart, okay? Be smart, do the right things, okay? Do the right things. It's not about investing a lot of time or like that. See, all problems are same. Roman Reigns, are you gonna spear me? Uh, yeah. Now I'm not doing much, but still, the thing is, don't make weird assumptions like you have to practice a lot or those things. Okay, you have to practice for sure, but like try to think too, try to improve, like try to see. The thing is, if you do some things well, if you improve your skill, we will do better, right? Okay, I mean, I'm not able to say much here. Okay, what you should do, what to do, probably work on the problem. Okay, some key ideas, look at the optimal. So what I mean is, say what you can say. What I mean is, when you're trying to find a procedure that works, let's say you're trying to find a procedure that works. Where am I? Yeah, when you try to find a procedure that works, you won't do these things. See, last time we discussed in speed.cpp that going in the wrong direction is the thing that takes a lot of time, right? Going in the wrong direction is the thing that takes a lot of time. So, what leads you to wrong direction? Trying to guess some procedure or working on the problem? Because when working on the problem, you don't say unnecessary things. You say most basic things. Looking at the optimal. So, what are you doing here? Here, you are not trying to find a procedure that gives you optimal, but you are thinking, okay, if this was the optimal, what can I say about that? If this was the optimal, let's say there was a subsequence. Okay, if this subsequence, if I1, I2 up to so on, I cap were the optimal, what can I say about that? DP or greedy? If the optimal structure can be brute force, then it is DP. If the optimal structure has something, uh, greedy means if the optimal, if some specific case is an optimal, like that taking the first one is itself is the optimal, then maybe it is DP. So whatever the problem is, it's about looking at the optimal. Okay, working on the problem, looking at the optimal, trying to see if there is a simple solution that you can get. If there is a simple solution, what would it be? So these are the things you have to do. I mean, what you're basically doing here is you're throwing the problem away. Like you're not using these facts. There's something have happened. So I will also solve some problems and show you people that these things are very real. Even in A, B, C problems, these things are very real. So what you should do is, what you should think in the mind is, if I can solve it, how would I solve it? But what would you do? What would you think in the mind? What you think in the mind is, if there is something I don't, if it is something I don't know, what would that be? Maybe I don't know, maybe I don't know, maybe I don't know something, like I don't even know, like this is what you do in the contest, like, or while solving. You should not be doing this, you should be doing this thing. If I can solve it, how would I solve it? That's all it takes. If I can solve it, how I can solve it. Okay, don't worry about this thing much at all. If there are some topics like if there are some topics needed, maybe you will learn them later. Okay, so guys, I want some volunteer. Okay, someone who can outsolve due to B, let's say. Is there anyone in that, like that? And don't be worried, whoever asked me about 1800 being stuck in an expert, I will also try solving some difficult problems in this stream. I think introduction is done. I'll try to solve some problems and show you people that how okay, give me a question that you are not able to solve. Maybe I'll try to help. Okay, give me a question that you are not able to solve. Anyone, any rating. I'll just try for that. Pinlay E. I have solved that, but then it's the same thing. Pinlay E is the same thing. See how I check my video, but how I have solved the problem is almost the same thing, right? Where is that? See, how I have solved is we can work on the problem. K greater than 3. See, if you work on the problem, one thing was obvious. First time it becomes greater than 0, all of them will be the same. So I brute forced on this thing. I brute forced on that thing, and then we can work small things in between. See, it's not about optimization again. It's about solving the problem. Okay. Okay. Another thing you guys do wrong. Okay. If you write a brute force solution, so okay, I'll keep this aside. Give me some problem link. Okay, you guys can't give me the link, right? So lost contest B. I mean, lost contest I have solved already, right? Give me an unsolved problem. It's not. See, you have to realize there are no ideas. CP problems are like to prove. If you get a code You can prove it instantly most of the times. I will do a video on that later. I will do a video called uh, okay, I'll try for this. So I'll do a video on how to prove, but then you have to realize all code forces problems have simple proofs. All of them have simple proofs. I hope it's not too difficult. Okay. I don't want to do this. Maybe I can do this. Like people get scared of these things. Maybe does it involve any graph traverse rhythm? I'll just select it. I'll select something less than 1400. Some easy problem. Count good numbers it seems. Okay. Let's try to why am I getting scared of all these problems? Okay, let's try to read this problem or solve this problem. Is that fine? Everyone read this problem and say whatever you think. Okay, we will go to difficult problems. After this, we'll try some 2200 or something, and then we'll try one more even difficult problem, and then we end the stream. We try to see the similarities in each level based on what I said. Okay. See, if you keep doing these things, you can solve easy ones, but you cannot solve difficult ones. But if you keep doing these things, you can solve all the problems. That if you keep doing these things, if you think you don't know, like you cannot solve any problem. But if you follow right ways, which are just simple, just these things, you can probably solve any problem. Okay, with time at least. You guys can't even see my eyes, right? Should I use specs? So guys, read the problem. So this is the problem. Read it. So how do I do that? I don't even have CPH. Uh, I don't even know if I have. So let's read this problem. Okay. Before getting scared, read the problem, see how these things will match. Okay. A prime number is a positive number that has exactly two divisors. So you don't need topics. Why? They're even telling you what a prime number is. See code forces problems are. See what is in front of your eyes. First focus on this problem. Next I will try some other problem. Okay. Let's focus on code forces. I get scared of AGC. Grand E. You're telling me to try some grand contest E. Is it an easy problem? It can be much more difficult for me, bro. Yeah, it can be difficult, but we can still work on the problem. We can try to work on the problem. Okay, if it is a game, I don't know, but let's first solve this problem and then I'll try to read the problem and work on the problem. Okay. No, I'll just stick to code forces. I'll try difficult problems too in this round if you want. So let's read the problem. See, why do you not need topics? Why did they explain prime number? Because you don't need outside things in any code forces problem. You don't need outside things. That's why they give you even the definition of a prime number. The first several prime numbers are they're telling 2, 3, 5, 7, 11. Prime factorization of a positive integer is represented as a product of prime numbers. For example, okay, they're telling what is prime factorization to. For every positive integer, its prime factorization is unique. This is some fundamental theorem of algebra, I guess. Sorry, fundamental theorem of number theory or real numbers of arithmetic, proved by Euler or Euclid, I guess. I think it's was proved by every integer greater than 1 can be. How you can prove this, I forgot. Now maybe it's a simple proof would be there for that. Uh, we can call a positive integer good if all prime numbers in its factorization consists of at least two digits. For example, okay, this seems like they should not have small prime numbers. All of them should have prime numbers greater than 7, greater than or equals to 11. Then we call it good, it seems. You have to calculate the number of good integers from L to R. How difficult can this be? You have to somehow calculate number of numbers. Okay, what are your ideas, guys? Anyone who don't have much rating, like anyone rated less than 1400, tell me their ideas. Like tell me whatever you guys ideas are. What is a good number? It's easy, right? What is a good number is easy. What is a good number? All its prime factors should be greater than n, right? Okay, your idea is fact. Okay, when you say factorize and check, you're thinking of the problem. Okay, what is the problem? Write the problem down. That's a whole another thing. Okay, good number, because this guy now, when he told just factorize and check, the question he is answering, what is the question? The question he is answering is how to check if a number is good or bad. But the whole question we have is to count number of good numbers. That's the whole question. We most of the times throw the problem away. Okay, this is good to say on a good number. So what is a good number? It's very simple here because they already told what's a good number. No prime factors greater than 10 or 2 digit, all prime factors. We need number of prime numbers, number of good numbers between L comma R. Okay, does L have any significance? If you guys think there are test cases using this fact, what you can say, you can only work on 1 comma R. If you need L comma R, you can just do 1 comma R minus 1 comma L minus 1. So this is one thing you can immediately say, because there are some test cases, right? And solving two times the same problem should be fine. So L comma R, L doesn't have any significance. And believe in what you should do, what to do. I think you should believe in golden rules, which says, so if you believe in golden rules, okay, solutions are simple. So if you find something that you can simplify, you have to do that. Listen this very carefully. If you can simplify something, you must do that. Okay, you have to look for what you can simplify. I'm telling you how you solve a CP problem. How you solve a CP problem is not by getting a great idea. It's by working on the problem. Believe that. If you can simplify something, okay, now these things are simplified. Now again you solve this. Done. Instead, you don't directly get some great idea and then everything gets solved. Okay. So you should not think, should work on the problem. You should not think some random things. Okay. So check if the number is divisible by this, remove all the numbers divisible by those. Total minus divisible. So yeah. So Gyan is not much high rated, right? He told he's 1150, but then he's telling how to do this. So when they say, so they wantedly told this, is there a simplification? See, there's a simplification. I told now look for simplifications. What are simplifications? You can simplify good number definition. All prime factors greater than 10. This can be simplified to no prime factor within 2, 3, 5, 7. Can you guys say why this is simpler than this? Can you guys answer my question now? Please be interactive. Can you guys say why this is simpler than this? Why? Why that is simpler than that? Say. Bro, I told one observation that L doesn't matter. Okay. L doesn't matter. Why? You can find 1 to R, you can find 1 to L minus 1, you can subtract those things. So that is one observation you can initially make. Okay. Because you have to think of how complex the problem is. 1 to R is enough. Solving 1 to R is enough. Okay. Not just limited checks. Here you have what are the prime factors allowed are so many, they are infinite, right? But now you came down from infinite possibilities to just 2, 3, 5, 7, which is very small. So in most of the problems, if you see the complement, it might, if the complement is simpler, we have to see for that. So if you don't make this observation, if you don't do this work immediately, you will be thinking something. But if you do this work, so that's why people who do these simplifications will go ahead easily, and who don't do will get stuck somewhere. Okay. So you have to do simplifications. You should not think of great ideas, okay? So now, no prime factor within this, or okay, what are bad numbers? So this is nothing but looking at bad numbers is easy, right? So total minus bad is the way. Okay, someone has already told, because this being simple, right? Okay, no prime factor. So what is bad then? Has a prime factor in 2357, right? Means divisible by either 2357, right? Either. Now if you know principle of inclusion and exclusion, this is a very famous problem, right? This problem is very famous. To know how to find number of elements divisible by 2 or 3 or 5 or 7, this is famous, right? I just took a head bath, bro. I'm going home tomorrow. I won't do much streams. My mom told she will cut my hair entirely. If you face that much of a problem, read the problem. Problem is just this. If you want the problem, problem is also here. This is enough, right? I'm not gay, but yeah. Oh, where are we? So, guys, if you, do you guys see? I told this important fact that if you can simplify something, you must do that. But you guys don't realize that. You guys try to guess some procedure. How do you get here if you try to guess some procedure without even simplifying the problem? Okay, see what we should do. It's simplified. Now if you see all the numbers that are divisible by 2 is, okay, number of numbers less than or equals to n and r and divisible by 2 is r by 2. That's it. This is r by 2. This is fixed. This is well known. But now if you know principle of inclusion and exclusion, you want union either by 2 or by 3. Okay, let's look at sets of d to b multiples of 2. Okay, less than or equals to r. M3b same 3. Okay, mi be multiples of I less than or equals to r. Okay, you need m size of mi union, sorry, m2 union m3 union m5 union m7. Okay, principle of inclusion and exclusion converts this into summation of mi minus summation of mi union mj plus summation of mi. You can think of it later. You can think how this is true later. Maybe you can use induction to prove this thing, because you have n sets and then you're writing the formula down, right? Maybe you can use induction to prove this thing. I'll try to prove this thing right now. Do you guys agree that a union b equals to mod a plus mod b minus mod a intersection b? This is true, right? This is principle of inclusion and exclusion for two sets. Okay, now let's say for this is true for one set also. Okay. Okay, now maybe we will use induction. Let's use induction to prove this. Induction on n. So if you have a1 union, a2 union, a3 up to so on, an equals to, what will I do? I will make this set first and then I'll write it like that. Then what will it become? A1 union, A2 union up to so on, A n minus 1 plus modulus of an minus a1 union a2 up to so on an minus 1 intersection an. Maybe if you can simplify this, you expand this entirely, and then you expand this one. Maybe you can see that. Maybe you can see that it's the same, not the same 1 minute. Maybe this is what it became, right? So I think you can do something here. I don't know exactly, but you can do something here, okay? So what you can do here is send this one inside. See, all these things union intersection, this is nothing but a1 intersection an union a2 intersection an up to so on an minus 1 intersection an. Don't think proving is time waste, okay? All induction ideas, dp is induction, right? dp is always induction, right? Okay, if you have the previous thing, how can you get the new thing? So if you have the previous thing as a formula, how can you get the new thing? So you guys see, things that don't look good, you have to keep doing them. Like, don't do something that looks fancy or fame. Just don't do things that look fancy like dynamic dp or so. I'm tired today somehow. Okay, if you see this now what are these things? These are all again. So these are like n minus 1 sets union modulo. This is again n minus 1 sets union modulo. Okay, do you see that? If you expand these two things, you get principle of inclusion and exclusion. Same formula, same formula with a1 plus everything, and then minus. Whenever an got included as extra, you have minus. So we have proven that. See how we have proven that. Do you guys agree that? I'm sorry for clashing, but I don't mind now. I can use bitmasks, but why to confuse anyone now? Bro, the thing is, focus on the problem. What we have converted the problem is into, if it is divisible by either of these, it's a bad thing. If it is bad, we count the number of bad things and then we do total minus bad. That is the way. Optimizations are not needed here, okay? Bro, don't irritate me. We don't try procedures, okay? See, okay, maybe the thing is, bro, the problem is solved, right? You want M2 union, M3 union, M5 union, M7. Okay. And see this thing. Number of numbers less than or equals to R and divisible by D, or R by D. Is this, do you agree this thing? See, finding union is difficult, but finding intersections is easy. What is something that is a multiple of both 2 comma 3? Their LCM is 7. That is the least common multiple, and you want some multiple of both of them. So intersection is easy to find. Okay, which is take their LCM and return R by LCM. So intersection is easy. So we use principle of inclusion and exclusion to solve the problem. This is done. Okay. What will I do with this 100 rupees, bro? But anyway, yeah, it's fine, I guess. Thanks. That's what I can say. Can we solve the problem? At least it shows that someone is paying attention to what I'm saying. Okay. See, all problems are same is what I'm trying to show you, that uh, that if you follow these things, it will work. So this, see, even this principle of inclusion and exclusion, it looked like it's very difficult to prove, right? But because I hoped, I send the thing inside. And then we can see why this negative signs will alternate in principle of inclusion and exclusion. Why? Because when you include one more element, sign is changing. Same formula, included one more element inside, the sign changed. That's why it is a1 minus a1 intersection a2 plus a2 intersection a3 intersection a4 up to so on. Okay, that's why the sign is changing. How to notice that? Okay, now where are we? We'll code the problem. int L comma R, C in L comma R. So solve for int R. Int answer equals to fun of R minus fun of L minus 1. See out answer. Okay. What is the answer? Just written r by 2 plus r by 3 plus r by 5 plus r by 7 minus r by 6. I'm taking two things. Minus r by 15 minus r by 10 minus r by what is left? 21, I guess. Okay, we have to go six things, right? Let's take 2 3 2 5 2 7 minus r by 14. I think this we should not write like this. We should do bitmask, but it's fine. We should do bitmask. Bitmask in the sense like go over all 2 power n possibilities. These are 2 power n possibilities, right? We are choosing some subset, right? Like this intersection is just choosing some subset. If the subset length is even, the sign is negative. If the subset length is odd, choose some things among them. That's what it is. But yeah, let me just write 6 things. 1 2 3 4 5. Only one is missing now. 7 5 is 35. Only this is missing. So now we have to add and divide other things. It's not easy. Hmm. Okay. Int f1 equals to, okay, size of one length elements is equals to this thing. But this problem is not at all difficult, right? Size of two length elements equals to this thing. Okay. What is size of three length elements equals to? Size of four length elements divisible by everything. This is r by tot, right? And what is this one? R by tot by 3 plus r by tot by, it's like taking three things. 2 plus r by tot by 5 plus r by tot by 7. Okay. And then what should be written? F1 minus F2 plus F3 minus F4. We could have used bitmask to brute force this procedure. Why? Bitmask means n bits 2 power n possibilities. In bitmask, you make it 0 or 1. That gives you, that lets you iterate all the substrings. Okay. I will explain bitmasks to right away. Okay. There is a bijection between set of all subsets and set of all possible binary strings of length n. Do you guys see this thing? Do you guys see that? If you have a set of size n, okay, 1, 2 up to so on n, and if you take its power set, okay, which is all subsets, take any subset here. We have some subset I1, I2 up to so on ik. So this thing corresponds to this binary string. If one is present, one is not present, 0. 2 is not present, 0. I1 is present, keep it 1. I2, and then comes I2, keep it 1. So this is a clear bijection, okay? So if you have to go over all subsets, you can use binary strings, which are nothing but bitmasks, if you want to call them like that. You can go over all possible binary strings and then go over all subsets. That's what bitmasks is. But this should solve the problem for now. Okay, I don't have CPP. This is a new laptop. I'll try some difficult problems too. I can do that, but I don't want to do that because for you guys, following what I'm already telling itself is difficult. For me also it's difficult. I cannot follow what I say. Many times I cannot do these things. I cannot do these things. I just see I can do that, but I won't do that for wantedly, okay? Where am I? See, if you guys don't know how to get started, go to custom test. Paste things here. Okay. Paste this thing here. Run it. And check it. If it gives wrong answer, you have to think what you have done wrong. 2357. 3 twos are 6. I'll make it 2357. 2357. 3 twos are 6. 5 threes are 15. 7 fives are 35. 5 twos are 10. 7 threes 21. 7 twos are 14. Everything is there. 1, 2, 3, 4, 5, 6. Correct. Also, this is correct. Right. If L is 0, all of them will be 0. And then we return 0. So what could be wrong here? Answer is R minus L plus 1 minus answer. Right. So now it's perfect. And then you can just submit it. What is the difficulty in this one? Maybe you don't know inclusion and exclusion, but it's quite famous. It's a very quite famous problem. The first time you can take time maybe. I can like that. Yeah. The first time you can take time maybe. What do you mean resources? I cannot just say keep practicing, bro. I'm trying to do streams and explain so many things. Try to follow one of them. Maybe you'll do better. Okay. Try to follow one of them. I hope when you guys ask me questions, I just feel like you guys are not hearing me at all. I don't know why I feel that. So now let's go to some difficult problem. Okay. And try to apply the same ideas. Now these people are messing with me. Okay, maybe let's try to do this problem. Okay, do you guys agree that? No, 1 minute. I'll try to do this problem. So okay, do you guys agree that this was true even in this problem? Even though it's an easy problem, this was true. Which was true? If you can simplify something, you must do that. Work on the problem. This was also true. If you should see if you can solve it, how you can solve it. Even if you get stuck here, you have to think of how to solve this problem for two things. Okay, we are subtracting six multiples. Maybe you can think of three things. Principle of inclusion and exclusion is not easy to get in one idea, but it is quite famous. Okay, it is quite famous. So guys, was this problem doable or not? Like for people who get scared in the contest, maybe if it was a newbie, he reads this, he doesn't even read the problem, he says L2R, he says 1E18, he pisses his pants, and then he looks at the timer, he waits until it finishes, and then he sleeps peacefully. Doesn't even read the problem. Okay. So now what I'm trying to say is all problems are like that. So let's read this problem. Whatever rating you are, we don't do it like newbie. We don't get scared. We just read the problem. You're given an array of length n consisting of. So guys, see what I want to say in this video again is that if you have very good clarity in your mind, what are you thinking? Then you can solve well. When you guys try for this thing, when you guys try to do this thing, when you guys start to do this thing, you're not even working well, you're not even working on a specific problem, you don't have a question in your mind. But if you try to ask these things, you have a question. Okay, can I try to simplify this? Okay, working on the problem, say what you say, looking at the optimal, you know what you're thinking, right? Okay, if this is the optimal, what can I say on that? Those are logical direct things. If you're not doing these things, you don't know what you're working on in your mind, you don't even have a question to solve. Okay, that's why I call it throwing the problem away, because you're thinking but you're not even thinking on the problem. You have to make sure that you're thinking on the problem. Okay, do you guys, I try to teach but you guys throw away whatever I say to you too. I don't know. See, realize this thing. We should not throw the problem away. All these things say throw the problem away and doing some bullshit thing. I don't know what this thing, but throwing the problem away, working on the problem, looking at the optimal because that was told in the problem to find some minimum or maximum or like to count something, trying to see if there is because of these facts we can say golden rules are true. Because of these facts, because there is already a solution exists, right? All cp problems, it's just difficult to approach that. It will be simple all the time. So yeah, trying to, so that's why what happens is you may not solve easy problems always quicker, or you may not solve difficult problems at all. You can yeah, it's not that good to do that. See, why it is bad to do is you're really throwing the problem away, you're really throwing that it has a simple proof, you're really throwing that there are checkers, you're really throwing that there are test cases, you're throwing everything, bro. At this point you're just joking, I guess. It depends on the, it depends on that newbie. Okay, if that newbie wants to stay newbie, he stays newbie. If he wants to reach master, he reaches master. Okay, it's a choice. Solving a problem or not solving a problem is a choice. It might, you might not like that, you may want a clear answer. What do you even expect by that answer? Do you expect like 3.43 years, Deepak? Was that your expectation from me to say you how many years does it takes to reach master? He had IOA experience too, but yeah. The thing is, he tries more too. He has solved so many problems. His speed is so good. I wanted to interview him. We planned of interviewing. I mean, I planned of interviewing him. We discussed, but then I'm not. He's not getting time, or I'm not getting time. I have to ask him again. I thought we will do an interview. He agreed to do on my channel. See, it's the thing is you have to be very positive too. Okay, you have to be positive, you have to make conclusions. See, I say okay in most of my things, I say okay. If you see, even he, I kept saying okay. Conclusions is not solving all the problem, but conclusions are like even small things I can say, I can see them as conclusions. See, if you, if you see, if you see any of these problems, okay, I'm telling some places that okay, this have worked more, but then let's say an easy problem. See, I told few things. I told okay, this was a conclusion for me. I mean, I thought this is a good thing. Like okay, if you see it as an edge, that seems I can work on that a bit. Even here, like when I ask some question, it won't solve the entire problem, but just the fact that there are only m levels, that itself is a very good thing to say. It doesn't solve the problem, but without writing this, it's difficult to solve the problem for me at least. I wrote that there are m levels, and that helped me to take the m biggest things and then done. See these things, like just writing the fact that there are just m levels, solve the problem. If you don't write this thing, see, you have to be positive too. Okay, okay, Gyan, you say you get the correct idea, all of that is fine. Okay, let's try to do some difficult, slightly difficult problems. Let's try to work on this problem now. Okay, you're given an array a of length n consisting of non-negative integers. You have to calculate the value, so you have to compute something and you have to output that. So when you have to compute something which is very big, probably you can simplify that, right? Otherwise you cannot compute it, you cannot do magic, right? You guys will really assume when you get scared of a problem, you guys will really assume what is the solution. You should never do that. Okay, you should never do that. So now where are we? So what is f of l comma r is XOR of these things, it seems. Okay, and this seems complex. You have to do 1 to n. Okay, for all this summation you want, n is big. So what are your thoughts? Tell me your thoughts. Yeah, I can try to. So that's one thing we can surely say. Yeah. Thinking of, okay, that's the first observation I would have told. But then I wanted to see you people's observation. But yeah, see guys, the problem looks complicated. But just writing the fact that it's bitwise, just writing the fact that problem sum over L less than or equals to R, f of L comma R, f of L comma R equals to XOR of AL to AR. Okay, someone told times, okay, times, yeah, where am I? So you have to write the problem down. Okay, someone told to look at bits. Okay, so that is coming from XOR, right? You can split this summation, whatever you have to compute, you can split that in terms of bits. So someone might have seen the XOR and might have given up. Someone might have seen the XOR and thought, I don't know XOR topics. All you need is XOR definition. Okay, all you need is XOR definition. You don't need topics. See, when people ask me topics, what resources topics, they don't use what they have and then they look for resources. Okay. Yeah, prefix XOR may be required. That's what I thought, Pradeep Gupta. But then someone told, think about the contribution of bit. Asphalt 8 is really good whenever I talk to him. It's not XOR basis. Look at one bit. I don't see, yeah, leave XOR basis. Someone will see XOR and get scared and won't solve the problem. But someone will see XOR and say, okay, can I solve the problem bitwise? See, here itself, you can ask yourself good questions. See, how to avoid bad work, how to do good work. In this problem, if you think of, okay, what if 0 less than or equals to a less than or equals to 1? If you think of this problem, that is good work. Why is this good work? Because you have to solve this problem, right? If you try to guess something, that is bad work. If you try to think of this, that is good work. How difficult is it like to remove these two things and then just see 0 less than or equals to a less than or equals to 1? Because your solution would finally work on this also, right? Your solution should finally work on this also. But if you see bitwise, if you solve this, the problem is done. Where are we? I got you. Sorry. I'll pin that for you for some time. I'll remove the pin too now. I mean, I don't know if you're joking or not because the questions people ask me, they have to be satire, but then they are not satire. Like, this has to be a joke, right? How long does it take to become master? That should be a joke, right? But yeah, so otherwise I would have thought, okay, I could have understood what you're doing. See, the thing is, this value can be f of L comma R can be splitted bitwise. Why? So XOR itself, name itself is bitwise XOR, right? Means you see these bits. So f of L comma R is you see those bits and then it comes. So what is it? This bit XOR into 2 power k plus this bit XOR into 2 power k. So this is nothing but bit C bitwise, and you can write it into 2 power k. So this total summation can be split into bits, right? So look at bits of ith bit. Its weight would be 2 power I into bitwise XOR of that bit. And the problem is same. Did everyone see that? Now, so if you can solve this problem, the problem is solved. If you can solve 0 less than or equals to a less than or equals to 1, why? Each bit is less than 0 less than or equals to a less than or equals to 1, right? Okay, the summation is big. XOR is given. What is simple? So you can work on each bit separately and then you can solve it. That's what it is, right? Which is equals to bitwise XOR, which is equals to bitwise XOR times 2 power I. XOR of ith bits. Take ith bit XOR times 2 power I. That's what it is. Summation. So it's all summation of summation of summation, right? Do you guys see that? It's like summation of summation of summation. If it is all summations, you can reorder as you like. So first I will, you can reorder by fixing this summation first. Okay. So it's like it has three summations. Summation of L, R, and then bits. That's what XOR is. You will fix this one first. If you see what you're doing, you're fixing this one first. So if you're fixing I first, now what the problem becomes? What the problem will become? It will become 2 power I times, okay, sum over f ith bit of L comma R times R minus L plus 1 times 2 power I. Okay, 2 power I already wrote. L less than or equals to R. So that's what it becomes. You have to sum this. Is this clear, guys? So what happened again? You simplified something that looks complex like XOR. You simplify that into bitwise into 2 power I plus bitwise into 2 power that. When you simplify that, you can work further. So what you have to think, is there anything that I can simplify to compute this summation or to write this summation in a better way? Even if you can't do the simplification, you can reduce the constraints and think how I can solve this problem. Yes, you can use CP to remove any fears you have, like, okay, because CP is about not getting scared. If you are someone who gets scared of IIT or I mean tags, like, why can't you be present? Why can't you take a problem and read the problem? Where did someone else come in the picture? Like when you want to solve one problem, why do you even see who is doing good? See the problem, solve the problem, right? It's just some cool problems. No one has, I don't know if you have some goals of becoming something or not. These are cool problems. Read the problem, try to solve the problem. If you cannot solve a difficult problem, go on easier problems, try to solve those problems, try to think, try to improve. Okay, you need not even see other people. I'm telling you to not throw the problem away, and then you're telling like you see someone else. What the fuck was that? I mean, we cannot help if you are someone like that. Okay, you should not. You should not. You should use what you have to the fullest, and then you can look at someone else. Okay, use what you have, and if you are someone who is using what they have well, you will realize that that's what you should be doing, because that's what you're not even doing. I mean, what I'm trying to say here is people who actually try to improve, they realize what they have, they try to use what they have even more better. But people who don't try at all, they are the ones who don't even see what they have. So what I'm telling, it's some problem with you for not using what you have or not seeing what you have. Okay, now we have to solve the problem for each bit. How do we solve the problem? So this looks very complex, but if all the bits are 0 comma 1, maybe this can be simplified, right? If all the bits are just 0 comma 1, then this can be simplified, right? Probably. So if all the bits are 0 comma 1, now we have only two bits. Now L comma R may be simplified. You need XOR of XOR over all subarrays, right? For all subarrays, you need XOR. Okay, means if a subarray has odd number of ones, its value is 1. If a subarray has odd number of ones, so now the problem is number of subarrays with odd number of ones. That's it, the problem is, right? It's just 1 hour and then we have done so much. See, we are simplifying it at each step. Say something, guys. I won't go against you. I want to know if at least it's getting recorded or not, right? Yeah. So yeah, so now we have to think of this problem again. How you have to believe that this is solvable. Okay, if this is solvable, sub arrays or n square, right? But we have to do it in O of n. How can we do it? Sub arrays or n square. But if you can do it in O of n, how can I do it? Maybe let's find something till I, and then find that for I plus 1. Okay, if you look at, so let's say you need all subarrays ending at I. Let's look at these things. Okay, I is here. Let's look at these subarrays. You want number of odd subarrays, right? With odd number of ones. Okay. So let's look at this one. If this was 0, what can you convert the problem into? If this one was 0, it's nothing but number of odd subarrays ending at I minus 1. If you see that, all the subarrays of size, look at subarrays. See, let's say you need all subarrays ending at I. All subarrays greater than or equals to size 2. Okay, can be seen as, if it was 0, it's like number of odd subarrays at I minus 1. If it, okay, if it was 1, number of odd subarrays. If it was 1, number of even subarrays at I minus 1, ending at I minus 1. Okay, so this is called DP. How do you know what all you should maintain? You try to find what you want, and then you see, okay, I also want number of even subarrays. So if you have both number of odd subarrays ending at I minus 1 and number of even subarrays ending at I minus 1, you can find number of odd subarrays ending at I and number of even subarrays ending at I. Maybe there are some other ways to solve the problem too. Maybe there are. Okay. Maybe there are some other ways of solving the problem too. Because if you see prefix XOR, someone told this idea again previously. If you see prefix XOR, okay, if you see prefix XOR, okay, instead of seeing zeros and ones, you see prefix XOR of them, okay. You try to see prefix XOR of them. If you see prefix XOR, you want, so in original array, XOR of A, L up to so on A or equals to, in prefix array, prefix or L minus 1 XOR prefix or. This is again a simplification. Okay. And you want these things to be different. Okay. If they are same, if they are same, if they are same, this will be 0. So now it again simplified. You have to choose two things which are not equal and whose values are also not equal, and then you are done. So what is answer? Count of 0, let's call it C0 times C1. Okay, and then the problem is done. If you have zeros and ones, choose a 0, choose a 1, take those two XOR. It's about choosing a 0 and choosing a 1, right? So answer is C0 times C1. Okay, you're choosing this 0, you're choosing this one. If one is smaller, other is smaller, you consider the subarray between them. The subarray will be 1. It's bijection. There is a it's like the same set. So I won't do this thing. This can be a DP approach, but I will just do this thing. I will convert that into prefix array, and then I'll just take count zeros, count ones, and then I will just return this one. It's that easy. Okay, it's that easy. So, should you get scared when you were given to sum over something like all subarrays? You should not get scared. Summing 0 over all subarrays is 0, right? Do you guys agree that? Summing 0 over all subarrays is 0, right? So when this is something over all sub arrays, you should not get scared of that. Okay, you have to work on the inside thing. That inside thing, if that inside thing is a random number generated over all sub arrays, then you cannot solve that. You must go over all of them. But what does that say if it is solvable? Okay, there is something you can say about that. Bro, you have no issues. You have no issues. You don't try at all. You don't try to spend some time working on a problem. You don't try to spend some time improving. Otherwise, it's not that difficult to see a path to improve. It's not that difficult to see multi-source BFS. What is BFS? How difficult is BFS? Say, how difficult is BFS? Okay, BFS just says, okay, let's say you have some graph, not even graph. BFS is the simplest algorithm you can think of, and then you're telling something, it's like a topic. What is BFS? You want shortest paths to everything, let's say. If you have from something, if you have everything, okay, the thing is, BFS is something so basic, and then you might, if you have heard DP, okay, see, I will once tell BFS and then I will try to say what you are trying to say to me. Okay, you need shortest paths from some vertex, let's say. Shortest paths from some, you want to find shortest distance from vertex 1. Okay, okay, look at optimal. Same thing. Look at optimal. You want shortest distance, right? Look at optimal. I told you to look at optimal. Okay, look at optimal. For V, you're going to find shortest path. Let's this be S1, S2 up to so on V. Look at this. Okay, let the length be sk equals to V. So what is the distance? 1, 2 up to so on k, right? Look at this one. Look at optimal. Okay, see sk minus 1. What does this say? V is coming from something previous. Can you say this is the this shortest to this is k minus 1? I mean, there is some vertex before that, right? Can you say if this is the optimal, also this should be the optimal, right? Because if this can be visited in a shorter path, that contradicts that this is optimal. So you have to logically be able to work on that. Okay, well, so now if you know all k minus 1 distance things, if you know all k minus 1 distance things, if k distant thing can be approached from any of them, then it is k distance. So it's not that difficult algorithm. Okay, if you are willing to solve the problem, you will solve the problem, maybe slowly. Okay, I mean, it's okay. This I complicated a bit, but then if you get all the vertices that can be visited in the first step with one distance, okay, you have all of them. Now try to see all the things that can be visited in two steps. All the things that can be visited in two steps will come from one step things, right? Right. And then you find all the things that can be visited at two steps. See, if you are willing to think, you will think. If you are willing to not solve, you cannot solve. Okay. Try any problems, try to see my videos. That's all the tip I can do, because I put so much content out, and then maybe see something, try to make some rules for yourself and try to improve a bit. Okay, yeah, like this is the most basic idea. See, when you know a topic, try to think about that problem, try to get that algorithm on your own. Okay, I would have done that. I have read them somewhere too, but then I would have done. Okay, these people say there are DFS traversals. Can I understand them well? Can I understand them slowly? Can I try to think of them on my own? I'll try to do those things. And then this guy goes, there are so many things I can't do anything. If you learn in the right way, there won't be many things at all. At all. Okay, it looks like I'm complicating things, but I don't know. So now see this one. It got simplified to C0.C1. Is this fine? Or is this too complex? It's just C0 times C1 times 2 power I. And then done. So how quickly can I solve the problem? See, it's c0 times c1 times 2 power I. So we can solve it very quickly. Int fun vector int uh, a, let's say it has 0 comma ones. Okay, and then I will find pref of n plus fun. Okay, pref of 0 is 0. Int I equals to 1, I less than or equals to n, I plus plus. Pref of I equals to a of I minus 1, pref of I XOR equals to pref of I minus 1. Okay, now we have prefix array. I have to include 0 too because subarrays I'm making them as I comma j. I'm considering I plus 1 to j, right? See, it's not you guys. If you work slowly, you will develop small things. You can improve well. Be patient, work slowly, try to improve things. Okay, because there are so many things. There are so many small things. But for all those small, see, it's not big topics that stops you. It's small things that stops you. In yesterday's D that I have done, I haven't used anything big, but I was able to use small things very well. If you see my E, nothing big was used here. Nothing big was used here, but so many small things were used. So many small things were used. I used that. I used reminder k minus 1 things. I have been updating this to reminder k minus 1 things. Here I used some simple combinatorics. I was able to partition them very well. Okay, last k minus 1 things greater than 0. That was this. Okay, last k minus 1 things are 0. And then first time greater than 0 happened here. So this is 0, this is 0, this is 0, this is 0. This and this 0 means these two are equal. This and this 0 means these two are equal. Reminder k minus 1 things must be equal. So with that thing, I'm doing k plus k minus 1 because I'm trying to maintain reminder k minus 1. So the fact is, it's not about big topics. It's being able to do small things so well. Okay, those things help you solve difficult ones again. Because if you see BFS itself, there is this small idea that anything that takes optimal k length will be coming from something optimal k minus 1 length. Saying this fact, writing the problem, looking at the optimal, if you can do these things, you will do them again and again easily. It's the same simple few ideas repeat, not even ideas, it's the same simple few work you do, they repeat all the time, like, and those things are very basic. What you should do is, like, you have to solve the problem, not throw the problem away. Okay, okay, so let's leave that. I don't know if it's about the mindset or not. I am not reading all of that. The only thing is that each of it may take a lot of time, maybe. Yeah, see, the thing is, if you're not willing to spend time, how much time have I spent? All of you have a lot of time. You do stupid shit all the time. Like, don't say like you don't have time. Like, people are bored, like, what, they don't know what to do, and then they try to do something to do what to do. Don't say like you don't have time. I don't know, like, you need not do CP, you can choose something else. My videos are like currently to help people who wants to do CP and who are trying more to do CP. Okay, maybe you can see something else. Even I see a lot of random things on YouTube. Okay, so now how quickly we can solve the problem. Implementation: c0 equals to 0, c1 equals to 0. For int I equals to 0, I less than or equals to n, I plus plus. C0 plus equals to pref of I equals to 0. C1 plus equals to pref of I equals to 1. Return C0 times C1. Okay, now we are here. Values are within 1 in 9, right? So for int j equals to 0, j less than 30, j plus plus, int answer equals to 0, I will form vector int b, which has bits. Okay, b dot push back of a of I and 1 power j. This is nothing but if that bit is active, bitwise and will give this as 2 power j. Otherwise, it will be 0. So if I keep it greater than 0, this will be 0 or 1 based on the bit is active or not. And then what is the answer? Answer plus equals to 2 power j times fun of b. How quickly can we do implementations? Implementations don't take time. If you don't know how to, okay, I messed up. If you don't know how to install, just use custom test because I don't know how to do that right now at the moment. There is something wrong. I think my hair is really troubling me. I have to do something about that. I thought I can save money without cutting hair, but then now it doesn't seem so. It's irritating a bit. Otherwise, you can use online GDB if CF is taking time. You can be quick, but don't make like typos like this. Maybe can I run these things using CLAN? Okay, I think I don't have bits. There is an issue here. It's supposed to be 12, but my algorithm says 3. Okay, I'm missing this part. This is some stupid part we have. So what do we do for that part? We maintain everything modulo capital M, okay? Okay. We have to also multiply this whole thing with, wait a minute. Did I fuck up something? Did I fuck up something? It's the length r minus l plus 1, not just f of l comma r. It's the length of the odd length summation. Okay. So what does that mean? It's like if you see, let's look at prefix or itself for simplification. If 0 and 1 is there, you have at l minus, if 0 is here at x and r is here at y, it is y minus x. Okay, it is y minus x. Okay, so if you know number of zeros before, if you know number of zeros before and their sum, okay, let's say number of zeros before this 1. Okay, it's like, let's say there are k zeros before, then what will happen? K into y minus their index sum, right? So if you maintain those two, we can solve the problem again. Seeing in this is, it's easy, it makes it easy. See, now prefix things helps. You must see them in prefix things, then it's easy. You either have 0 1 or you have 1 0, 0 1 or 1 0. If it is 0 1, you have to know number of zeros are there before, and you have to know there's indices sum, because y minus x is the length of the array, right? So what I will maintain is, I will maintain this. Okay, so I will also maintain s0 comma s1. Okay, s0 plus equals to pref of I equals to 0 means we add I to that. S1 plus equals to pref of I equals to 1 means we add I to that. I'm going a bit quicker here, but you guys see how important was it to see prefix XORs. Seeing prefix XORs simplifies that. Again, same idea. Whatever simplifies, you have to do that. Seeing prefix XOR simplifies n things, L2 OR, many things to two things, which is pref of L minus 1 XOR pref of OR. You're XORing many things, you're XORing two things. That's why it's simplified. And XORing two things, you can see they should be of opposite. So far, how many zeros are there? Where are there? Their summation. I'm just summing this x. Summing this x is nothing but S0. I want, it is nothing but now C0 times Y minus S0. Okay, y will be added number of zeros times c0. You're just summing this thing so many times. X1 x2 up to so on will be stored in c0. Number of times this has occurred would be c0. So answer plus equals to, if ref of I equals to 1, answer plus equals to c0 times I minus s0. Answer reminder equals to m. Maybe I can make this also reminder m. Else answer plus equals to c1 times I reminder m. See, it's all about simplifying things. Okay, don't complicate it with I see tags on someone. Don't complicate it with, see, you guys are making things complex for yourself. You guys are making things like, okay, there are topics. Okay, I will complicate the competitive programming for me by assuming that there are so many topics. There are this, there are that. The whole competitive programming is about, given a complex problem, try to simplify things, try to say some things, and then solve the problem. And then you say, I will just take some other route. I will just try to think that, okay, everything can be complicated. There are some sheets, I have to follow those DSS sheets. Maybe I have to look at the problem, see, try to solve the problem, try to simplify things. That's what competitive programming is about. But then you guys make it complex, like uh, maybe I have to first learn this and then I have to come here. Maybe I have to, even if you don't know CPP, start and try to see how I can do it without CPP. I learned CPP by solving watermelon or some other problems. In my first contest, I don't even know CPP in my first contest. I just gave it. I just gave this one without even knowing C++. Okay, now I have solved everything, but in the contest, I don't know C++. I solved the problem. I saw how to input and output C++, and then I have done that. I took 1 hour 8 minutes, but yeah. I told test cases I will store them here. I stored all the test cases and then I solved all the test cases. See how good was that? I don't even know that we need not store test cases. I was like, okay, I'll store test cases and then I'll solve test cases. Haha. And what did I do after some days? I tried doing B. January 13, 2021. It was January 8, I remember 2021. And then I tried solving them a lot. And then it got accepted on 14th. And then January 14th, I tried this one, it went wrong. And then again, July 20th, I was able to accept that. I remember this. I remember solving that. It was seeing some things like this. It has those things. It has that pattern. Uh, it has that up below thing, I think. Okay, this was something else. Maybe I was thinking about the someone. Okay, maybe I was thinking about B. Yeah, B has that up below things, I guess. I struggled a lot on that and then I solved the problem. next 2 days. I think I wrote something very big. See, it can probably solve simpler. Initially, I don't know, so I was using rep. But then I realized the problems are not about typing quick. The problems are about doing well. So I came back to for int I equals to 0. I write them down. It's not like I have to be very quick. You should have a lot of energy, bro. What are you? Getting stuck somewhere? Segmentary people copy paste. So okay, let's see if this will get accepted or not. Okay. Because we are subtracting something, I'm trying to make everything like that. Let's also make s0 reminder equals to m, s1 reminder equals to m, and also make sure that that's it. So that's it for the stream, guys. I don't want to make it longer. I have things to do. See, it was very easy because we simplified it into prefix array. It was very easy to change it quickly. Something is wrong here. Now let's see if the problem is solved. How did it become easy? Because we can simplify that into prefix array. Okay, where is the problem? Guys, the problem's gone. Can you guys help me with problem? I get it, but what I'm telling will help to even become grandmaster, I guess. Even though I'm not a grandmaster, it's not roadmap. Like it's doing the same things, but not doing the wrong things. How is this guy number two? But they're spamming. Guys, I'm ending the stream. No, I won't solve that. I'll remove you if you keep doing that. I wanted to interview him. We both thought we will interview each other, but then see, Shreyan has achieved LGM. So what you guys should do is you have to see how you can do better. That's it. We don't need segmentary even at 2600 level. Guys, don't irritate me. Can you guys help me with some problem? Like, where is the problem link? I don't want to open my history here. What is the problem? Can you guys give the problem again? It's fine. I'll open the history. One, three, one, two, three. It says 14, which is wrong again. Right? It should be 12. What do I know? I thought order doesn't matter, but order matters, right? It is 12, so it's likely correct. Let's verify some other things too, okay? Oh, there are no test cases. If there are no test cases, we can remove this thing and then we can paste our solve here. We could have made t equals to 1 2, but why? Why to hurry? This looks cleaner, right? It's correct. Now we are here. What do I know? It's correct. So it's probably correct solution. I used prefix array simplification. So it's again simplifying things. I want to solve at least one difficult problem because you guys are irritating me. Okay, it says in queue. Anime recommendations. It's a new laptop. So guys, let me solve one difficult problem. Okay, not much difficult. We'll see what are the ideas in a difficult problem. Okay, is it about simplification or not? I'll keep 2600 and I'll at least solve 12600. Okay, if you show what all I have solved so far, I think we have solved quite a lot. This is all in contest. When did I solve this one? Okay, this I solved in practice. I remember. I even kept this in my group. Where did I solve this one? Okay, this is a bad problem. I don't like that. This is a good problem, I guess. I like it. That's very small solution, I guess. Not so small. This is a good one. Just this and then it was done. Simply. Light. But if you see here, there are many 2600s done. Long back, I used to solve very much. In 2023 or something, I used to solve more. Now I'm not solving much. So yeah, let's try to solve one 2600 problem and then stop this. Okay. Done. Yeah, I have done that. Let's check out his videos if we can. Will he have a grudge against me now? I don't know. Like I told him to not spam, oh, right? We just don't want others to get disturbed. So let's try to solve one problem here. However, this problem again already. Yeah, I have read this problem already. I'm stuck in that problem a bit, but yeah, let's try to read some other problem. Okay, let's try to read some other problem. All this, wait a minute, something have happened here. I don't think all these things are 26. Flashing lights. How is this 26? I think something is broken here. I think something is broken. What about 26 to 3000? Oh, this is 2900. The one I sold on stream. Okay, nothing is broken. 26 or easy, let's go with some 26. Okay, let me open this or open this or open this or open this or open this and open this. We'll read all of this and we'll try to solve at least one among them. Okay, we'll read all of this and then we'll try to solve at least one of them. I know it's not made for. I want to just see how it will be if it is difficult for me too. Okay, you guys can say you're taking all easy problems and then you're just solving them, right? So let's try to read this problem. Okay, we have this one also. Interactive problem. So let's try to read this problem too. Okay, 160 operations it seems. We have even also. It's good that we have even. We can work on even and then we can work on E2. So let's try to see this problem. Okay, interactive or not, like let's we have to solve the problem. Okay, you're given a tree of n nodes with node 1 as its root. You're given a tree of n nodes with node 1 as its root node. There is a hidden mole in one of the nodes. To find its position, you can pick any integer x to make an inquiry to the jury. Next, the jury will return 1 when the mole is in subtree x. So what are they telling? There is one hidden mole. You have a tree. Even if you don't know a tree, you can follow the video. Okay. You have a tree. Why is my Chrome slow? It's a very good laptop, right? You guys see my email and spam me. So tree is nothing but something like this. Okay. Tree is nothing but one node points to many same trees. So what is it? What is tree? Let's say rooted tree. You have one and then you again have same tree structures. Same tree structures. So recursively it can be defined. Tree is either one node or one node that has some trees below that. That's what a tree is. So most of the time you solve problem for this, solve problem for this, all of this, and then you solve problem for this. You do it recursively. Whatever the tree definition is, the problems on tree also are like that. But here, if you see here, to find its position, you have to find the position of the mole. It seems there is some hidden mole in this tree. Something is hidden. Okay, in the tree, something is try this problem, guys. Okay, can you guys say who all is trying this problem? I want participation, right? Who all is trying to read the problem and try the problem? Leave a W. I don't know if someone is present or not. I don't want to do streams if no one is watching them, right? Keep W or something, guys. Yeah. So we have people. So we will try this problem. Okay. We will not be scared. We'll try this problem. What does the problem says? There is a hidden mole. To find, see, these problems are good, right? These problems are good. The problems are good. Focus on this problem, Niketan. If you respect my answer to your question, you should respect my what I am doing to, right? Next, the jury will return one when so if the mole is in that subtree, jury will return one. Otherwise, jury will return zero. So these are the information you can have. If judge returns zero and mole is not in root node one, the mole will move the parent. Okay. So there is something happening. this complexes the problem a bit more, right? What is happening? The judge returns 0, but we don't know. It increases the problem, but we don't know if this complexes or if this simplifies. Maybe we can solve the problem because of this fact, right? So if the judge returns 0, the mole is not in root of node 1. So you chose a subtree where the mole is not there. Then it moves above. The mole will move the parent node of its correctly node. So there is something happening. If you choose some subtree that is not here, the mole will go above. Find the current node where the mole is located. And then we output it like that. So, okay guys, do you guys understood the problem? Do you guys understood the problem? We have a tree, there is a mole. You ask about one subtree. Subtree means everything below some node V is its subtree. This is its subtree. For root, this is its subtree. Okay. And if the mole is present here, and if the mole is present here, you will be returned 1. If the mole is present here, you will return 1. You will get 1. But if the mole was not here, the mole would have been somewhere and then it moves above. Okay. And then it moves above. So here n less than or equals to 5000, here n is less than or equals to 5000. Queries here you should get it within 160. Here you should get it within 3300. Okay, that's the problem. So we understood the problem, right? Yeah. So does this problem need topics? Yeah. So if the height is less than or equals to 300, the problem is done, right? If the height of the tree, are we given tree? Yeah, we are given tree. If the maximum height, so someone gotten a solution. If maximum height less than or equals to 300, can we solve it? We can keep querying leaves. Okay, someone gave some solution, because if you query leaf, what does that mean? There is no mole here. Okay, and then you remove that leaf. Let's say if the height is less than or equals to 300, if you keep doing that, it keeps going above. I think you can do something. Okay, you can keep removing leaves or query something. Okay, query something. If the height of this, okay, if it is 0, if it is 0, if it is 0, if it is 1, right? If it is 1, you can discard everything else because mole is here. Maybe you can keep querying this itself, right? Mole is in this thing. So the problem will become the same problem. You need not see anything else now. You can only see this thing. And you wait at here. And you wait at here, like if the mole comes here, you have to know that. Okay, I'm trying to use more logic. That, okay, if I know one, what can I say? Mole is within. I won't let it go outside, kind of. If you keep removing, okay, see, binary search or not comes before some logic. Okay, I'll remove these people. It's not, I don't know about thinking or not. Let's try to just think of the, do you guys agree that it is at least thinkable? So you have to think of now I will try to work like if I work. So one thing you can say is if it is 0, it keeps going above, right? If you are querying one, so height less than or equals to 300, right? So what I'm trying to do is, maybe if you split them into heights, we cannot do more queries. Okay, we cannot do like WOF level queries. We cannot query some whole level. If height is big, what we should do? You guys can think, okay, if it is a line graph, what will I do? If it is a line graph, if the tree was just a line, how to do that now? Maybe binary search on tree, as someone told, right? If this was a line graph, you can binary search. Because it's very too many nodes, 5,000. You have to binary search and find if it is here or not. Okay, if it is not here, so if it is not here, it might have moved above. It might have moved above. Okay, but how do you binary search? Okay, you have to binary search, let's say. So if you know that for a tree within this subtree it is existing, right? I think you have to remove some big subtrees. Okay, you have to remove big subtrees. So I think if this subtree is 0, you will remove that. So I think you have to take some big subtrees and then remove them. So the idea, rather than binary, okay, binary search is good on the line graph, but here to binary search on height, I'm thinking one height may have many levels, right? One height can have many nodes. You cannot say, you cannot query all of them and see if mole is present in the bigger height or not. But if it is 0, you can remove so many things at a time. You can remove many things at a time. Okay, this seems good. You can remove many things at a time. This seems good, right? So take some subtree of size less than or equals to 300. Take some subtree. What is root n? So this makes it like you keep removing big things. Then it makes it like n root n kind of thing, right? Not n root n. It makes it like, okay, if the height is if the height is small, if the height is less than or equals to this, keep querying leaves, or keep querying some, okay, keep querying leaves. Done. If you keep querying leaves, it will come into top. Okay, if height greater than 300 or like big, then find something with height 300. Find some subtree with height 300. Find some subtree that has at least size greater than or equals to 300, because now we are greater than 300, and ask it if it has 1 or 0. If it is 0, you can remove all of that. You can remove all of that. So you're removing so many things. Means you can proceed at max 5,000 by 300 times. Okay, which is much smaller. So it feels like this idea, right? It's like you have to remove many things, otherwise you go there and do that, like a root n kind of thing. Root n means root n means as long as height is greater than 300, you keep removing these things. You keep removing these things. Okay, as long as height is greater, and when height becomes small, less than 300, you can just do anything. If height is less than 300, keep removing things, and then, I mean, you can remove them or you can do something, and then it goes above. Okay, so this seems to be the idea, right? I'll remove this one. If they misbehave one more time and not focus on the problem and keep some shitty things. Aristotle is here. Why can't I go down? Yeah, binary search is not extending. That's why I'm telling maybe like n root n. Maybe like n root n is what I'm telling. That seems fine right now. Do you guys agree? We find a subtree of size what? The thing is we have to remove many things is our goal. Okay, whenever it is big, we have to remove many things. If it is zero, we can remove the whole subtree, right? Because the mole only goes above. It can never come into this subtree. So we will try to take some subtree of height greater than or equals to. It's not 300. Let's see what is root of 5,000. What is root of 5,000? Root 5,000 is just 70. So guys, so let's do like this. Okay. If height is less than or equals to 70, keep querying leaves and remove them. If height is greater than 70, okay, if height greater than 70, find something with height 70 and remove it. If it has 0, but if it has 1, then how can you focus on only this now? That's the problem now, right? How can you focus on only this now? That is the problem for us. Maybe we will solve for 300 queries first. So, how do you make sure? We cannot do this multiple times. We have to find it and then we have to do this, right? Okay. So if it has one, we can focus only on this subtree, okay, and keep querying same thing. We can keep querying same thing. We can keep querying the same subtree, right? Keep, keep querying the same subtree. The mole moves up, 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 and after 70 operations, the mole crosses this. And then it's in the parent. The first time it became 0, it's in the fuck. If it is 1, it doesn't cross. If it is 1, it doesn't cross, right? Okay, if it is 1, keep removing leaves. Remove a leaf. If it is 1, remove a leaf, query for everything. Remove a leaf, query for everything. Okay, remove a leaf, query for subtree. So if it has 1, so you found some height with this. Remove a leaf, query for the subtree. This seems correct, right? When you remove a leaf, like if the leaf gives 1, you found it. Else, if the leaf doesn't give 1, what does that mean? uh, Leaf doesn't has that. You can remove that and then you query the whole subtree to know if it is still present or not. Okay, and if it is not present in the subtree, then it has went to its parent for the first time. So after each query, you you check parent, check v. Do you guys get it? I'm sorry, Atharva. I think there are other channels that helps you to do such things. I'm just telling, mine thing will require a lot of effort. It's difficult here. Okay. My excali says no space is present. Okay, guys, I have to end the stream. So, guys, currently, see, we are trying to find a subtree that has the mole of size 70. And if you find that, once you find that, such a subtree, you can remove leaf. So our goal is to find a subtree. See, 70 is like a small subtree size, let's say. Okay, you try to find query 70 height thing, and then you ask if there is a mole, and then your goal is to focus only on that. If there is not a mole, you remove the whole subtree, and then if you keep doing this, you can do this at max 70 times. Okay, and within those 70 times, that has you find some subtree that has a mole. Okay, you found something that has a mole now. Okay, now this subtree has a mole now. So now you keep removing leaves. You remove leaf, you check this thing. You remove, now you know that this subtree has the mole. You remove this leaf, you check this one. You remove this leaf, you check this one. You keep doing that now. Okay, you keep doing that now. Now you know this subtree has that, right? It's 70. What you do? You remove the leaf, and then you, because in this subtree it is there. If the leaf was 0, it tries to go above somewhere. Okay, and once it reaches that, you remove leaf again, and then you query, and once this thing becomes 0, what does that mean? It just left above. It just left above, and then it will go one more above, because it was not there here. So it went above, just so here it went above. When you have removed this one, it went above, and then you query, it became 0, and then it might have gone above again. So you just go to two parents above, and that would be the answer. So how many operations? This is 70 times 2 operations, right? This was 70 times 2 operations. This was 70 operations. 70 operations in finding that, and then 70 times 2 operations in finding that. This is 210. So in 210 operations, we can solve the problem. So if even can be solved. Okay. Do you guys see that? But initially, to find that subtree, we are doing 70. That's sad one, right? To find the initial subtree, we are doing 70. To find the initial subtree, you do 70, and then you have this thing. So can you make it root 70 again? Can you apply root n logic on this again? Let this be 8. Okay. You will try to again apply the same logic. Okay. You try to remove root n lengths, and then you check two things. If it was 0, you check two things. What? You check this and then this. So now what happens? If you do root n things after finding this 70, on this thing you're doing root n things, you will find some subtree of size 8. Okay, in how many operations? In 70 plus, in 70 by 8 operations at, okay, in 70 by 9, let's say 9 9 is 81, right? In 70 by 9 times 2. So if it was 0, you will check the above thing again. Okay, you're removing more than one leaf, and then you will check above thing. So it is 70 by 9 into 2. These many things, in doing these many things, you will conclude one subtree of size 8. You will conclude this subtree of size 8, height 8. Okay, Now you can remove at max 8 things. Now the subtree size, its height itself is 8. Now you keep removing 8 leaves. You keep removing 8 leaves plus 8 and 8 into 2. So how much is this thing? So the problem is surely solvable. Maybe there are simpler implementations. We have to think about that. But the problem is 9 sevens are 63 or something. 18, 16. This is a very small number. Check them out, bro. It's not new techniques. It's analyzing what you're doing now. Tanay, take a problem, solve the problem, try to analyze what you have done. Try to see not I don't like the term patterns. So I don't like the term DSA. I don't like the term patterns. I'm starting to hate DP2 because of how people use it. The term, I mean. So where am I? Try to solve problems. They don't need topics. Yeah, random problems. Try to take very difficult problems, like not very difficult ones, to 2200, 2000, or those are not difficult at all, right? So guys, we solved 2600 problem by applying that logic again and again, right? We solved this by applying the same logic again and then it was done. See, this itself is 26. So here, idea is not difficult. Okay, idea is not difficult. But implementing this may be difficult. But if we solve the problem, we can implement this, right? Implementing also won't be difficult. Maybe there is a simpler idea. In the worst case, we can implement this. Otherwise, maybe a simpler idea in the sense, maybe we need not do it again. Maybe we need not do it again. But maybe we can do something better, okay? What do I know? Why not remove, because we are needing two operations per height, right? We are needing two h operations per height, right? We are needing two h operations per height h. So why not make this height even smaller? So instead of 70, let's say it was 35. Okay, what is 500 by 35? 142. So you take 142 operations to find one one subtree. You take 35 that many operations. Okay, so it is 142 plus again 35 times 2, which is more again. It's again coming around 210. So we have solved the problem, but then we're looking for a better way. I retired, bro. I retired from CP. Yeah, at least logic wise, it's not that hard, right? So we'll see how difficult can even is solved. Okay, for even what we do for even, we keep removing subtrace of size greater than or equals to height greater than or equals to 70, or equals to 70, not greater than. And if it has that, you keep removing its leaves. Remove leaf, check that. Remove leaf, check that. Remove leaf, check that. And once the first time this becomes 0, then you can for sure say that So we will solve the problem recursively. Okay, how will we solve the problem recursively? We have this one, right? If this one is greater than or equals to 70, it will remove them to something height less than 70. Okay, that's what your function does. So what your function does, you have this thing, right? We can maybe we can define our function. We can use recursion to our advantage. Let's define our function that if you do DFS on this subtree, it removes it removes things, and then what will be finally left is height less than 70. If height is greater than or equals to 70, it removes them. And if height is less than 70, it finds the node in that, and then it uses 2 into 70 operations, and it finds and it ends the solution. That's what it does. Okay, so that's our algorithm. If it finds the mole, if it doesn't finds the mole, it makes it less than 70, height less than 70. Okay, so height less than 70. If it finds the mole, it makes it high. If it doesn't find the mole, it makes it height less than 70. If it finds the mole, it it finishes the job. Okay, that's our algorithm now. If it doesn't find the mole, it makes height less than 70. If it finds the mole in this subtree, now we cannot do that. Okay, we can do that. It tries to keep removing from below. So yeah, this is our algorithm. Like, this is our recursion. What it does, it keeps, if it takes this subtree, it keeps removing less than 70 things from bottom, and if it finds some node that had, it keeps removing less than 70 things from bottom. Okay, and if it finds some node, it the problem is done. If it finds some node, when it's removing something like that, if it finds a node, the problem is done. But if the problem is not done, then what happens? If the problem is not done, then you removed all of them, and then there is something less than 70 is left here. All of them are less than 70. Okay, okay, so now you have this one. If so, okay, let's simplify our solution even more. What it does is, what it does is guys, I'm ending the stream. Should I try to code at least this 70 times 3 thing, or should I just end the stream? I think if you use recursion, we can remove them well. So the main part is we have to remove more things correctly. I'll remove this guy too. He's asking questions which can be verified so easily. Yeah. So we will implement this. At least 210 thing can be done. What is the rating of the 210 thing? I don't know. But at least 210 thing can be. 1 minute. For n square is allowed for implementation, guys. N square is allowed for implementation. I was thinking O of n for implementation. N square is allowed for implementation. Okay. All of you are telling O because of the n square, right? See, we have thrown the problem away. So now we have solved 26.2, right? If n square is allowed, implementation should not matter now. I will find size 70. I will again remove 8 things among them. I have checked. I have checked. I have checked. I think both are similar. So guys, 70 to find a subtree of height less than 70 with the mole operations plus now again we remove 8 size 8 subtrees. We can remove size 8 or height 8, anything works. Size 8 or height 8. I was trying to do height, but size 8 also works. We take size 8 subtree, remove them. Size 8 subtree, remove them. Size 8 subtree, remove them. So then how many things will become? This is size 70 subtree, right? In these many things, you will find a subtree that has you will find a subtree that has things of size, okay, that has the mole. And so now this thing has the mole, and for all until you find that, you do two operations, right, which will make it 70 by 4 plus once you found that, you can remove again all of them, 8 into 2. So is this less than 160? 70 plus 70 by 4 plus 8 into 2, 103. It seems less. So we can implement this thing, right? At least easy one. So now what do I do? Because n square is allowed, right? What do? I come from biggest heights and I keep coming above, and then I keep finding number of active nodes to be greater than or non-removed nodes to be greater than or equals to. I will find one subtree of size 70 and remove that. That's the first process. And once you find that subtree, now what do? Just keep removing leaves, keep checking above. Keep removing leaves, keep checking above. The first time this becomes 0, go 2 parents above, that's the answer. 2 parents. Why? You remove that, you check that. Now itself, the answer is 0, means it has already went above. If you do one more time, it has gone above. So yeah. So now the problem is done. Is this not doable? Does this need topics? It's like you have to remove most of the nodes, right? If you take level wise, why not binary search is we cannot binary search on height that easily, but n root n seems right. So what I do? I remove few things. First I will implement that one. Okay. 71 be our value. 70 also works. Okay, it's just n root n. How difficult is an n root n idea, guys? It's 2600. I mean, it's not that easy. But if you spend some time, okay, if you spend some time positively, and the problem got solved very instantly. If you look at me, how it got solved to me. Okay, I will have something called size. I'll just make it b of n. Okay. So void dfs int v int h int p. This will find the size. Let's say b of v equals to removed of v equals to 0. Okay. It will find the subtree size for everything after even with removals. If u not equals to p, Done, right? So this, after you remove few things, you can know. I will also find heights. Why not? Or you can find the smallest thing greater than or equals to. You can also find the smallest thing greater than or equals to 70. Or you can find the height and then you can come like that. Let's just find smallest thing greater than or equals to 70. Okay. So we, and then we'll try to find the node with the smallest node greater than or equals to 70 things, and then we remove that. Okay. How to remove a subtree? Remove int v. This is a subtree. Okay. I'm trying to remove this subtree. Done. We wrote a functionality to remove a subtree. We have a functionality to see the subtree sizes. Okay. And if we find the subtree, we know what to do. We remove, we focus on this subtree, we remove something in this subtree, and then something. Don't even bother it to be a leaf. Okay. Okay, if it is one, you're in trouble, right? If it is one, you're in trouble. If it is one, if it is one, we have to focus on this subtree now. Why to write recursively? Let's just remove leaves. Okay, let's just remove leaves. Let's just remove leaves. Okay, if you remove leaf, it was one, it went to leaf's parent. Let's just remove leaves. Removing leaf is not difficult. Okay, why? You have to see this subtree, and then you have to take one leaf. You have to see this subtree. Whoever size is one, remove that. Removing leaves is easy. Okay, we have this remove functionality. We have this size functionality after removals. Okay, so now what do I do? I will find something, minimum thing greater than or equals to 70. I will find. Find minimum thing greater than or equals to 70. Okay. While true, I have to find something, minimum thing that is greater than or equals to 70, and then keep removing them. Okay. Until we find something that has 70 things and that has a leaf. While int found equals to false. I mean, we will surely find such a thing. Okay. So int v be 0. This is the first 70 we find. Okay, first 70 thing we find. So what do I do? I will do dfs of 1 comma 1, finds everything for everything. Okay, now int uh, let's say u equals to 1, u equals to 0, pos equals to, let's just keep it like that, u equals to 1, its size equals to what is that, size equals to b of u. If size less than 70, break. Okay, if size less than 70, break. Otherwise we can remove 70 things by querying this. How do you query? Okay, size greater than 70, find minimum thing greater than or equals to 70. Okay, find the minimum thing greater than or equals to 70. Why? There will be something like that. I think we have to focus on height. We have to focus on height. Why? Because But size also works. Size also works. We can focus on height or size, anything works. But I'm doubting if there will be something of size 70. I'm doubting something, guys. I'm doubting something. What I'm doubting is there will always be, if you keep removing 70 things, okay? If you keep removing 70 things, I think should we go for size or height is my question. Because there can be something with size less than 70. 1 minute. It feels fine. Size seems fine. But can you find something 70 is doubt? Maybe you will find something which is much higher size or much lower size. Just take this 69, 69, 69, 69, 69, and all of them are attached to 1. So this is the problem with size. You cannot logically guarantee that this problem won't occur with height for sure. But you cannot, okay, you can remove this, you can remove this, you can remove this, you can remove this, you can remove this. But then you're not removing something less than or equals to size 69, right? So that is the problem. It may not exist, but height always exists. Height 70 will always exist, right? So if you take the minimum size, will that work? Minimum size. If you take the minimum size, if you take the minimum size, will its height be? If you take the minimum size thing, minimum subtree greater than or equals to 70, will it height be less than 70 is my question. It may have more things, but will it height be small? Because if its height is small, you will eventually go above. Right? You will eventually go above. I'm being very careful, okay? Will it height be small? Is my question. Why? If its height is greater than 70, okay, how big can its height be? How big can its size height be? Think of it. You have this subtree. This size is less than 70. Otherwise, this would have been removed, right? This height is less than 70. All of them heights are less than 70. Size itself is less than 70. So this height is small. So that's why we can do it. I was just making sure. I was just making sure. Okay. I was just making sure the size is small because sometimes we might end up with some big subtree, right? We don't end up with size less than 70, but we end up with height less than 70. For sure. See, I'm being very clear, okay? Here, you remove this thing, you end up with something not size less than 70. You end up with something with height less, uh, with with height less than 70. If you keep removing these things, the thing you find by taking the minimum, so we are not trying to, okay, by finding, by removing, okay, by removing size less greater than or equals to 70, you find a subtree with height less than 71. Why? By removing these things, you may not find something with size less than 71, but you will find something for sure with height less than 71. Why? Because its children, all of its children's size is less than 70, right? So all of their height is less than 71. So this works. I was just being very clear, okay? I was just being very, very clear. So this works. Minimum thing greater than 70, that size may not be, the size of that may not be, the size of that may not be 70, but the height of that will be 70. And if its height is 70, our 70 into 2 algorithm works because it's going above, right? It works. So do you guys see how I'm trying to be very clear in terms of logic? Great, bro. Pawn of the board. Yeah, in that we keep removing and then we find something of height small. Okay. See, both versions are solved, but for order version, we have to repeat on 72 further. So I am here now. So I'm just making sure. Okay, I will find something that is greater than or equals to 70, minimum thing greater than or equals to 70. Okay. Implementations are also easy. If b of I greater than or equals to m, 70 is m, and if b of I greater than or equals to m, if b of I less than size u equals to I, size equals to b of I. Okay, we are finding the smallest size which is greater than 70. Smallest size which is greater than 70. Okay, now what do? We query this node. Smallest size greater than 70, also height less than 71. We query this one. If, and then we find the result. If x, what should we do? If not x, what should we do? If not x, we do remove of u comma u. If x, what do we do? If x, I have to break. I can even return. Problem is done. If x, what should I do? This is having that, right? We find leaf in that, we remove that leaf. To find leaf and remove things, if we just, so vector int I want those things. We have to keep removing leaves, right? If you go in the order of their heights, or sizes, that would work probably. If you go in the order of their heights, it works. If I go in the order of their sizes, will that work? Will that work? We are going in the order of the sizes. So first we'll remove all the ones. Okay. And once this size came, it will be a leaf. If you go in the order of sizes, that also works. Once this thing came, all its subtrees must be removed because they have smaller sizes. All of them are removed, so this is a leaf, so that also works. So vector int, I will store parent also, okay? Mhm. So now I want its subtree. How do I get its subtree? How do I get its subtree? I want to collect everything in this subtree now and then keep removing them based on their sizes. I'll do DFS of 1 comma 1 again. Okay. I'll do dfs of 1 comma 1 again. I'll just do this thing. We want it subtree, right? Let's use basic thing. Vector in, let me keep it pair. Subtree, let's say, okay. If so, we'll keep going to parent, okay. Int v int variables. What variables should I use? If int u equals to I while u not equals to 1, we'll keep going to its parent. If u equals to, oh, we found u, we cannot use that. F j, I'm just going above and I'm going it to its parents and finding if j equals to u. So you found j equals to u. Okay. J equals to parent of j. So j equals to 1 will be missed here. If 1 equals to u, found equals to 1. This is also true, right? If 1 is equals to u, then so this means I is in the subtree of u. Okay. If found, this is just something simple. We can do something else too. I is in subtree of j. I can even use this thing also. Get subtree. Void get subtree. Okay. Int v comma int p. Okay. Vector pair int. Let that be subtree. Okay. For int u adjoint of v, if u not equals to p, not removed of v, I can even use this thing. I can even use this thing, right? I'm going over that subtree from, and then I will just push them if it's not needed. If it's not removed, I'll just find that. Uh, Fuck. People keep asking, okay, does this have any topics? People keep asking me like what we should do for topics, right? Does this have any topics so far? Fuck it. We solved the problem. We saw the implementation. It's not happening. I'm ending the stream. Simple implementation, right? Simple implementation. Literally going over just two loops. I'm ending the stream, guys. Bye. What have I done in Lost? What have I done in Lost? Yeah, I'll say it again. Maybe we collected the subtree, we sorted it based on its size. If you remove all smaller sizes first, and when you come at u, v, all its children are removed because they have smaller sizes. So this is a leaf, and now you queried a leaf. If leaf is having one, that means that is the answer because it won't go above, right? If leaf is having zero, you'll check the subtree to still see if it is inside. If it is inside, you can repeat the process. If it is not inside, you have that means its parent's parent is the answer. Why? Previously it was inside. Now when you have queried that, it might have gone out. And then when you asked it, it was out. So it will go again above. So parent's parent is the answer. And then we done, we return. I didn't say it for you. I thought for video people it should be there, right? That's what I thought. Okay, guys. If this is correct, we have 170 thing now. We do the same thing. Okay. We do the same thing. Instead of removing leaves, we remove 8 leaves. We remove 8 subtrees of size 8. 8. 8. Okay. And once you find an 8, then you do the other thing. Okay, bye. I'm ending the stream.